Okay, so this is our boat trip project by John, Carter, Brandon, and Zach. So our project we had mechanical engineering, and we decided to take a look at how the gears, the material behind them, the different designs of them, and like the designs of the machines were impacted by the designs of gears and how we could change those gears. So the materials that we decided to use for our idea would be an expensive material, but it would be more higher quality, which would be aluminum bronze, to make sure that they were able to withstand longer and we didn't have to take as long to replace them. The designs of the gears would depend on what they're being used for. The bigger ones would have more power behind them. They would take longer, but the smaller ones would have faster rotations, but they would be more finicky and used for the smaller operations of the gears. It was also important for us to find what gear ratio we needed to make sure that the gears were optimized in a way that we could be used. Corrosion was a big part for the gears that we were using, because since it was a coastal area, salt water corroded the gears faster than it would normally. So we needed to make sure that the metals that we used were more resistant to corrosion. We wanted to make sure that the metals were more dense because they needed to be stronger because they were used more often in coastal areas. And also if a machine fails in coastal areas and things get wet, it's a lot harder to repair. What role does chemistry play? Basically, we were looking at the building blocks of the different machines, which are gears, and chemistry is the building blocks of the elements that like make the gears. Our team was Carter, Brandon, John, and Zach, with Carter being the team leader, Brandon being the team facilitator, John being the project manager, and Zach being the research facilitator. Some of the challenges that we faced are being able to find time during times that we had different schedules and different commitments that we had to do, and coming together on a single idea. But we made sure to plan around everyone's schedule and make sure that everyone's input and ideas were out there when we were choosing our thesis.
Hello, I'm Zach. I'm the people on the team. So we had several original theses. Our first one, which was the one that we ended up going with, was the first thing that we thought of whenever we got assigned mechanical engineering for our problems. It was gears and what type of gears, that the metal and how they are being affected by salt water and the coastal environment. Our second proposal was thinking about how much destructive forces is on the coast and how structures need to have redundant supports and just built to survive the extremes. Our third thesis was how bridges consume a lot of energy being used and how we can lower the energy cost. And so that's that thesis. Thesis 4, we're talking about how buoys can be moved over time and how they can move themselves back into the right position, especially as of different terrains change over time, that could be implemented there. But we didn't end up going with that one just because it wasn't so related to mechanical engineering, along with the last thesis, which was more on the communication side and more electrical side, since that was more communicating boat to boat from across the ocean, making it more safe. We shouldn't see how it correlated or not with the mechanical engineering. Now, figure one of the places we visited on the boat trip was the SS Selma. This is a boat that is made out of concrete and rebar, and we can show how much rust all of the metal has gone through, and just the corrosion and just mass amounts of damage that the ocean has done on it.
Hi, my name is John. I am the product manager, and I got to play the role of building these slides together. And we're looking at our figure 2 here at Pelican Island Causeway. We got to see the on-ramp that we take every day to go to school and see how dependent it is on gears and how much mechanical requirements it needs. And just connecting that back is just seeing the requirements for each process that we have. And then with the even larger bridge on the causeway, we get to see it being used, and this is a daily use, and it's heavily used. And we can see the gear actuation and usage, and it's being incredibly exposed to the sea. So these gears need to be built to withstand heavy use, heavy need, and heavy surrounding like difficulty. Then we use the oil rig as an example in our figure 4, where we get to see that it is a complete monstrosity of mechanical devices, where it has cranes, it has the drills itself, it has tools that it needs to live every day and to serve its purpose. And all of these are constantly moving around to be an amalgamation of parts. And so it does connect into our idea where each of these are serving a purpose overall, and just really well implement the ideas of having good quality materials, good quality design, and thorough thought processes and how much we're going to use them. And with our figure 5, we got to see the USS Texas, which is a battleship that is being repaired. And we can see how much rust damage it is and how much damage it has taken, and that it's served its purpose, but it's being repaired, and it's used thorough materials that have lasted the stand of time, but also need to be repaired and have had the thought process of being repaired. So that goes over a majority of our figures, and that just cuts out really our visual aspect of our paper.
Hi, my name is Brandon Lee, and I was the team facilitator, and now I'm going to discuss the sources that we use for our project. Our first source was the Gear Solutions magazine for the research into the gear industry by Brian Dangle, and this was very important for us so then we can determine the alloys that were best used for the gears and whether like their resistance for corrosion and which ones we would determine are best used for our project. And then our second source was the pack rust identification, and this was mostly used for the Selma and how we were able to determine the corrosion involved around it, and then also how we can avoid that corrosion that was on the Selma. And then our other one was the types of gears, and we use this one so then we can learn which gears would be utilized best for the bridges that we were designing, and then also just the designs that would be best appropriate. And then another one was the types of drawbridges we can use, so then we can determine the gears and then also the requirements for the strains and also the environments to determine which bridges and gears were best suited for each other. And then this was also another source that we use so then we can determine a bridge in a different environment, so then we can see how it affects what is needed to build a sustainable bridge for a coastal region compared to a city region. And then thank you for listening to our book project.
9 minutes.
This one.